we've learned about every component of our quadratic equation and what it does to the graph. We're going to put it all together. On the first day, we learned about this A value. It does a few things. Now, a lot of this stuff you're already going to have in your notes. You do not have to write stuff again. If you feel like you know where to reference all this information in your own notes, feel free to not write it down. If you want everything in one spot, you can write it as we go through. But a lot of this stuff you have written down. This A value determines two things. First, it's going to determine if your parabola is opening up or down. What's the difference between the two numbers that would do that? Yeah, if my parabola is going down, it's represented by a negative. Also, this number is going to dictate if my parabola is wide or skinny. Again, things that I can control with that coefficient. If I notice that that number is extremely large, it's going to make my parabola skinnier because it's growing at a faster rate. If that coefficient is small, like a fraction, it's going to keep my parabola wide. It's not growing at a fast rate, whether increasing or decreasing. After we worked with that coefficient of x squared, we started to build in the concept of this C value. This C value we identified was the y-intercept. Now, when we didn't have that B value, you could see that it actually moved your graph up and down. But if you ever needed to create a table to find the y-intercept, our y-intercept represents what value? The value of y when x is 0. So just looking at this equation, if this first term you had an x of 0, that becomes 0. The middle term, again, 0 times anything is 0. You would be left with a C value. So that proves why it represents your y-intercept. And then yesterday we started to talk about this B value. We already knew that A changed the shape and direction. C changed the up or down, like it shifted it. So B had to really move it side to side. It was the only other direction that we were left with. That B value moves your axis of symmetry. So after we go through this summary, the Desmos activity today, you're going to match a parabola, and you're going to have to write the equation that represents the line. And you're going to have to play around it and figure out if the parabola shifted, what value of the equation should I be changing? How should I change it? So I want a larger coefficient or a smaller coefficient. Again, none of this is new. These are all things that we've gone over. We did a different topic each day. Now we're starting to put it all together. Now, if we're looking for a process or a way to graph a quadratic from start to finish, we have some options. You could always just plug values into a table. The limit, it could be a problem because at some point your quadratic is going to turn. We already know that the quadratic looks like that U-shaped graph. If you're not sure where that's going to turn, it could be a bit of a challenge. So to combat that, finding the axis of symmetry first is highly recommended so that you not only know where your parabola is going to turn, but you also can use that value to find your vertex. How would I find my axis of symmetry? Who remembers from yesterday what we utilized? Oh, we're going to use the B value and what else? And the A value. How do I use them?
Negative B divided by 2A.
Could I write this another way? Oh.
B divided by
However you prefer to calculate that is fine. It's the same thing. It represents the same thing. We can actually multiply -1/2 times B over A. Right? This helps us find the vertical line. We already know that a vertical line has the equation x equals that number, and it's the x value of the vertical line. That's what this calculation is going to help us find. We're going to find the axis of symmetry, and then we're going to use that value. Why is the axis of symmetry going to be essential in finding the vertex? Because, okay, we'll know when it turns, so we're going to know that moment where we can find our lowest or our highest point. And where is our vertex always found? It's always found on the axis of symmetry. So this vertex is a coordinate. an x value and a y value. The x value of our vertex is the value that we're finding from this calculation. So if you find the axis of symmetry, you're halfway to finding your vertex. The vertex here, we're finding by using the x value from the axis of symmetry. If we substitute that value into the equation, we will find the y value that makes the equation true, meaning that point is on our line. So this one calculation, negative b over 2a, is going to allow us to find not only our axis of symmetry, but it's really going to take us to our vertex as well. And if we're talking about being as efficient as possible, starting with your axis of symmetry will be the most efficient way for you to graph. Now, once you have the axis of symmetry and the vertex, you know where your parabola is going to fold, you know one of the points. Then we can use the y-intercept. If you know where the axis of symmetry is, finding the y-intercept actually gives you 2 points on your graph. The reason being, okay. If I know that line of symmetry, if I find any values on one side, I automatically know the sides on the other because it is a direct reflection. So that last value, if we find it, and this is just an example, if I knew that my vertex was here and my y-intercept is that green point, by plotting that point, if I already know my axis of symmetry, again, you can hear the stress in my voice of how essential that axis of symmetry is. If I know the y-intercept, I automatically know a point on the other side. If this point is 2 units away, then I have a point that's 2 units away in the other direction. That would allow me to graph a line. Typically, we would want more points. If that's the farthest you can go, you at least know a few things. You know the direction that your parabola is going. You can identify if it's going to be really skinny or really wide. And you also have enough points that you could show a curve. So while we normally want more than 3, if you could only get that far, you've done enough.
That's the bare minimum.
Yeah. And that would be okay. Now, the reason why we try to go through this step by step, very infrequently, are you going to be asked to go from start to finish. Here's the equation, fully graph it. What's going to happen, and you'll notice it on some of the part questions that we see, they'll just say, find the axis of symmetry for this equation. What's the calculation you would use to find the axis of symmetry? What's another one? What is the coordinate for the vertex? So they're not necessarily going to want the entire thing. A lot of times they'll stop at the axis of symmetry or the vertex. That's why we try to go through each one. Question? We're gonna try to do. We're gonna do 2, and I'm not gonna have you graph them. Okay. So for these two, not this one. For these 2, I would like for you to do 3 things. First, find the axis of symmetry. I was going to calculate, but. Second, find the coordinate of the vertex. And third, coordinate of the y-intercept. You are not graphing. We don't need to see the graph right now. I'm most concerned with, can you find these values for these 2 equations? So you have 2 equations. Y equals negative x squared minus 4x plus 1. And the second equation is y equals 2x squared plus 8x plus 6. use the calculation that you have to find the axis of symmetry. Using that axis of symmetry, that value, find the coordinate for your vertex, and then find the coordinate for your y-intercept. We're gonna take like 6 minutes, okay? You're not graphing it. That is the time-consuming part of this entire process. Just find the values. If you know the values, you know enough to plot the points.
Guys, can we turn this in?
vertex would be the x and y, so it would be 2 times
Oh yeah. No, you're right. For the first equation, who wants to share the calculation you did to find the axis of symmetry? Patrick.
I don't know if I'm right. So you first do the thing with the -b over 2a,
Okay.
and the negative b will be positive 4 over 2 times -1.
Good.
So that's positive 4 divided by 2. Negative. Oh, you're not. Which is -2.
Good. So my axis of symmetry, if I were to graph this, would be -2.
Oh.
If you calculated -1/2 times b over a, you could have done it that way as well. Signs are really important. So we have our axis of symmetry. Who wants to share how we can use that axis of symmetry to find our vertex, the coordinate for our vertex? Say it again. I can substitute a -2 for x, so this becomes for that first term, what do I calculate first? The exponent. -2 squared is what? 4. Then what do I do? Multiply by -1. So we have -4
Plus 8.
plus 8
Plus 1.
plus 1. What's that calculation? 5. Which means the coordinate for our vertex is where x is -2, y is 5. And what's the y-intercept? 1. So where x is 0,
Pardon interruption, students. James Langston, Nayeli Gordiano, please report to the main office with your belongings. James Langston, Nayeli Gordiano, please report to the main office with your belongings.
now that y-intercept is going to help us because if I know that 0, 1 is a coordinate, that means 2 units in the other direction of that line, I have another point because they're opposite each other. That would look like that. Who made mistakes with the negatives?
I did.
Believe it or not, that is what people mess up most of the time. It's not even the b over 2a, like the negative b over 2a is the calculation. So it's kind of funny when you're learning this new material that it always comes back to that, multiplying positives and negatives that we did in early middle school.
Squaring the -2. Wouldn't -2 times -2 be a positive?
It would, but then this is a -1 here. So if we multiply -2 times -2, it's a +4, and then times this -1 becomes a -4. For this second one here, what did I calculate to get my axis of symmetry? -8 over 4 because 2 times 2.
Yeah.
So -8 over 4, which equals
And -2.
-2. Also -2. So same axis of symmetry. So we'll write this one on here as well, but I'll do it in red. Using that axis of symmetry, I'm going to substitute in here. Again, exponent first. -2 squared is 4 times 2 is 8. 8 times negative 2 is negative 16 plus 6. And that equals negative 2. Last, I know my y-intercept is positive 6. So it's here. So my graph will look like this. That's that negative b over 2a will not be provided on the part of the exam. You'll have an anchor chart in the room that will help you when we take assessments. So by the time you get to April 30th, we want to have that committed to memory. As much practice as possible with that, we'll definitely have it. Mm-hmm. Yeah. Okay.